probability from percentage data. That's our topic first. All right, so the information is going to be given in percentage form. Then how do we find probability from that? So let's look at a simple example. If the problem says 20% of, now remember the probability is a ratio of how many elements are in the event as opposed to how many in the sample space. So let me write down on the screen, probability of E is count of E over count of sample space. So we are basically dividing two numbers to get a fraction. And so let's say it's 1/5. I mean, for a specific problem, it comes up 1/5. And if we convert it to decimal form, it's equal to 20%. So when I say 20% is the probability, it's same as saying 20% of the sample space is in the event. That's basically what it means. The ratio is 20%. 20% of the sample space. If the sample space has 5, there will be 2 elements in the event. If the sample space has 10, there will be, if sample space has 5, there will be 1 element in the event. If sample space has 10, there will be 2. The ratio is still 20%. So that's what it means. It's a ratio. So if I say, so basically, if I say the probability is 20%, probability equal to 20% means 20% of the sample space is in the event. And so that means if there are 100 elements in the sample space, there will be 20 in the event. If there are 200 in the sample space, there will be 40 in the event. So to find the probability, so let's take a simple example. It says 20% of class has A in the test. All right, what does that mean? Whatever the class size is, 20% of it has A. So the ratio is what we care about. And so 20 out of every 100 has A. If there are 200 students, 40 students have A. If there are 150 students, 30 students have A. But we only care about the ratio. So we can say, we can assume there are 100 students, then 20 students have A. So the probability to get A is 100 students in the class, 20 students have A, so 20 over 100, which is the same as 20%. So what I'm trying to prove here is, if the problem says 20% of the class has A, then probability for a randomly selected student to have A is 20%, the same number, because it means 20 out of every 100, and that's exactly what probability means, the ratio of how many got A as opposed to how many in the class. That's exactly what the probability is. So therefore, probability and the percentage information are same. So if they tell you a percentage, if they give you a percentage information, that is the probability. So, so here's an example. So basically, this is the fact is stated in this box here. If n% of items are in the event E, then the probability of E is n%. Now you can convert it to decimal form, fractional form, but that number itself is the probability. So here it says in this example, in a math test, 10% received A. So that means probability for a randomly selected student to have A is 10%. So 30% received B, 40% received C. If a student in the class is randomly selected, what is the probability that he or she received A? The answer is? Anybody?
10%.
10%. The probability that the student received B or C?
40 or 80%.
40 plus 30, right? 30% received B, 40% received C.
Oh, 70%.
20% received B or C. That's right. Other than A, B, or C, to find how many received other than A, B, C, we had to add these percentages 40 plus 30 plus 10, that's 80. So
80.
20%. So 20% received other grades, right? If I add the percentage 40, 30, and 10, I'm getting 80. So there are 20% left. Those must be with other grades other than ABC. So the answer to part C is 20%. Okay, now the question is, if the class size is 40, then how many received A? Okay, now 10% of the class received A, or probability to receive A is 10%. Now, how many students actually received A? If the class size is 40, that's 10% of 40, right? So the count of A, number of students who got A is 10% of 40. Notice that the 10% is percentage information and it is also probability. So this is equal to 4. So if they give you probability for getting A as 0.1 and ask you if the class size is 40, then how many students are going to get A? That's still probability times 40. Probability is same as percentage. So the probability multiplied by total count gives you the count of elements in the event A. Event A is getting grade A. So that's another point that is coming up under the title expected value. But I just wanted to use that example. So the answer to the question D is 0.10 times 40, which is 4. All right, so this is exercise. So I expect you to answer the question. In a medical office, 60 staff are there. 15% are trainees. The staff is selected randomly. What is the probability that that staff is a trainee?
15%.
15% or 0.15 in decimal form. Normally, they expect you to enter the answer in decimal form. You enter percentage only if they ask for that one. Okay, then it says how many are trainees? What do we do to calculate that?
You just find 15%
Multiply.
60.
Say again?
Multiply 0.15 with 60.
Right, 0.15 times 60. 15% of 60 will be the trainees. So 0.15 times 60 is correct. Next one says, what is the probability that he or she is not a trainee?
85%.
85%. And so how many are not trainees? 85% of the 60. So 0.85 times 60. Okay, very good. Now the expected value. I just explained a minute ago. Basically, if they give you probability for in a problem, 0.6, that's same as saying 60%. So probability to pass an exam is 0.6, means 60% of the students will pass the exam. So if 300 students took the exam, how many will pass? 60% of 300. That's how many are expected. Now we call this expected number because this is applicable not only for the past classes, also for the future classes. Like this. If I say, in my Math 108 class, I have seen 60% of the students pass the exam, pass the course. All right, if I say that, that means, as a fact, as a general fact, in Math 108, 60% of the students pass. Or to probability to pass a Math 108 class is 0.6. If I say that, that applies to all 108 Math 108 classes. So next semester, I have, let's say 100 students in my 2 sections. So how many are expected to pass? That would be 0.6 times 300. So that's why we call it expected number. It applies to future as well. So the expected number to pass is same as probability, in this case 60%, times 300, total count. So expected value is same as probability times total count. So that's one formula you need to remember. Expected value of an outcome is equal to probability for that outcome times total count. So let's use that in this example. From past data, it is this exercise. So I expect you to answer that. From past data, it is estimated that the probability for a student to pass a state proficiency exam is 0.6. And if 340 students take the tests this year, how many are expected to pass? Okay, what did we do?
0.6 times 340.
Right, 0.6 times 340. And how many are expected to fail? That's same as 0.4 times 340, the opposite remaining probability, or the remaining students. Whatever you found as answer for the first part, subtract it from 340 to get the number of students who are expected to fail. So to answer the second part, either 0.4 times 340 or just subtract the answer for the first part from 340 to get the answer for the second part. Okay, so it's very simple. Expected value means probability times the total count. So let's go to this next exercise. In the English 201 class, 18% are white, 9% Hispanic, 12% African American, 5%.
I'm sorry, Professor.
Yeah.
What would we do to find the answer to the second part again? I'm sorry.
Okay, two ways. One is, let me erase the board here. Use the board. Yeah, I thought, I'm sorry, I rushed it. So let me explain the second part. One way is this. If I do the first part, let me get the pencil. Okay, first part is, part A is 0.6 times 340. Okay, and that comes up 204. Yes, 204. So 204 students are expected to pass. The second part says how many are expected to fail. One way to answer that is to say 340 minus 204, right? 204 are going to pass, so remaining students have to fail. And so 6, 3, that's it, 36. So, no, I'm missing something. 10 minus 4.
136.
136, right. Thank you. So 136 will fail. So that's one way to answer. Another way to answer is, if the probability to pass is 0.6, remember probability for an event and the probability for the complementary event add up to 1. We saw that in one example. That's coming up in the, those facts are coming up again. But the two probabilities have to add up to 1. Probability for passing and probability for failing, complementary. So therefore, probability for failing is 0.4 because probability for passing is 0.6. So we can do this. We can say number of students failing equal to 0.4 times 340. And that's equal to 136. Okay, so you can find the complementary probability and multiply by 340. That's another way. Okay, you got it?
Yes, thank you.
You're welcome. Going on to exercise 17, in English 201, there are 18% white students, 9% Hispanic, 12% African American, 5% Asian. A student is randomly selected. What is the probability that the student is white or Hispanic? Anyone?
27%.
27%. What is the probability that the student is of a race other than those listed? If you add them, that's 27, 39, 44. The total is 44. So,
56%.
right, 56% will be the other race. Now it says, if 4 students sign up for this course next semester, how many are expected to be African Americans? What do I do? Multiply
0.12 times 40.
0.12 times 40, that's right. How many are
I'm
expected?
sorry. Letter B was 56 or 66?
56.
Okay.
Part B is 56% or 0.56. 40 students signed up, then next semester, then how many are expected to be African American? That's 0.18, no, sorry, 0.12 times 40. How many are expected to be white or Hispanic? The percentage for white or Hispanic, 18 plus 9, 27, so 0.27 times 40, right? Okay. So nothing difficult about these ideas, expected value. And that is,
I have a question.
sure.
When I did this, I got a decimal. When we do it on WebAssign, should we round it off?
It will tell you if they want to round. Normally, yes, you have to round it, and usually the problem will tell you where to round.
Okay.
Okay. Normally, if they want 2 decimal digits, they'll say round it to 2 decimal digits or round it to the 100th or whatever. They will clearly tell you.
So for the first part of C, I got 4.8. And how would I round that off in WebAssign?
I see what you mean. Yes, how many are expected to be African Americans, and you got 4.8, then you answer it as 5. The number will be whole number for this kind of question, right? So you round it to the nearest integer. Okay.
Yes, thank you.
You're welcome. And you have 3 chances. If you fail to round it and it says wrong, then you should realize that it needs to be rounded. Okay, that finishes 10, worksheet 10. And we are moving on to the next one, which is properties of probability. Now, the probability topic is going to be pretty long. It's covered by 2 chapters in your book, so it's pretty long topic. And at the end of probability, we'll have the second test when we finish probability. That'll be worksheet 14, I believe. We are at 9, so we have a long way to go. So let's understand the properties of probability. Definite event and impossible event. A definite event is an event that will definitely occur. An impossible event means an event that cannot occur. There are very simple examples I can give you. If I toss a die and if I say event E is number 1, 2, 3, 4, 5, or 6 false, then that event is going to happen because the number is going to be 1, 2, 3, 4, 5, or 6. So that's a definite event. And if I say another event, F is numbers 1, 2, 3, 5, 6, 1, 2, 3, 4, 5, 6 do not fall. We don't, what is the event says this is not. The number, the outcome is not going to be one of these numbers. Then that event cannot happen. So that is impossible event. So if I calculate the probability of the event E, as you can see, E has 6 elements, which are same as elements in the sample space. So probability of that event is 6 over 6, which is 1. So probability of definite event is 1. If it is going to happen, then the probability will be 1. The second event, the numbers 1, 2, 3, 4, 5, 6 do not fall means what number is going to be outcome? Nothing. There is no element in this event. So F has no element. F is empty set. And when the F is empty set, the probability equal to 0 over 6, which is 0. So the point I'm making is definite event will have probability 1, impossible event will have probability 0, and all other probabilities will be between 1 and 0. So they will be all fractions. Now you can see why they are fractions. And probability is defined to be count of elements in E divided by count of sample space. So the count of E is normally smaller than count of sample space. The highest it can be is equal to sample space. So therefore, this will be always a fraction. The largest value it can get is 1. The numerator and denominator can be equal. That's the best you can get. Numerator will never be larger than denominator. So it will never be a whole number other than 1. So one property we have just learned is always probability will be between 0 and 1. The lowest value it can be is 0. The highest is 1. All right, so let's understand complementary event. Complementary event of the event E is E does not occur. So that's what we call complementary. E not occurring. So let's look at an example. If E is defined as outcome is a number less than 3, then, I'm tossing a die, E is any number less than 3, that's the event. So sample space is 1, 2, 3, 4, 5, 6. Event E has 1, 2, and the probability of this event is clearly 2 over 6, 1 over 3. But what is the complementary event? The complementary event of E will be the outcome is not smaller than 3, right? Not happening. That event, E not happening, is same as the outcome is not smaller than 3. So that'll be same as saying 3, 4, 5, 6. So the complementary event is basically same as complement of this set in this sample space, with sample space being universal set. Now we learned about complements before. So 1 and 2 are the elements in E. So the complement will be 3, 4, 5, 6. So if E is not going to happen, if E is not going to be the actual event happening, or E should not happen, that's same as saying the outcome should be 3, 4, 5, 6, which are the complementary elements. In other words, the complement of E. Basically, to find the complementary event, you can find the complement of E with sample space being universal set. So that's what you need to do. So complementary event is 3, 4, 5, 6, and the probability of that is going to be 4 over 6. So probability of E is 2 over 6. Probability of E bar is 4 over 6. You can see the numerators add up to 6 because they do have to add up to 6. If one is complemented to the other, then the number of elements in both events have to add up to 6. So that's why if I add probability of E and probability of E bar, I'm going to get 1 always, because the numerators add up to same as denominator. So so the two important facts here. One is a complementary event is same as complement of the given event with the universal set being sample space. So in the sample space, you find the complement of the given event, and that is your complementary event. And probabilities of two complementary events will add up to 1. So if they're going to add up to 1, we can use that fact to find complementary events probability. So I'm going to the board. If the problem says probability for the event E is 0.3, what is probability of the complementary event? Okay, we know that probability of E plus probability of E bar is always 1. So we can rearrange this equation to have probability of E bar on the left, then probability of E will go to the right. I mean, if you subtract probability of E from both sides, then you have 1 minus probability of E. So you can use this to find probability of E bar. Also, if they give you probability of E bar, can we find probability of E? Yes, we can rearrange this equation in a different way. Probability of E equal to 1 minus probability of E bar. So if they give you probability of E bar, then you subtract it from 1 to get probability of E. or if they give you probability of E, you subtract it from 1 to get probability of E bar. So if one is given, you can find the other easily by subtracting from 1. So now we can answer questions like this very easily. If John has a 0.6 probability to pass his math course, what is his probability to fail? What is it?
0.4.
0.4, the complementary probability. It's as simple as that. All right, so now let's go to the Venn diagram. We used Venn diagram in the set theory, and it's going to apply throughout the probability theory. And so I need to explain something about Venn diagram here. Let me clear the board. So let's say now in the probability theory, your sample space is the universal set. So you always use a rectangle for the sample space because that is the universal set. So there are whatever the sample space is. Let me use some numbers just to make it clear. So let's say there are 100 elements in the sample space, and there are 40 elements in here in this event. That's event. Then there are obviously 60 elements in the outside. So what is the probability of A? Anybody?
40%.
Right, 40% or 40 over 100. Let's try it as a fraction. There are 40 elements in the event and 100 elements in the sample space, so 40 over 100. And probability of the complement, A bar, is
60 over 100.
60 over 100. Now, probability of the sample space. And the sample space is a definite event, right? If an event is equal to sample space, then it'll definitely happen. So we can say probability of the sample space is 100 over 100. There are 100 elements in the sample space. I had to divide by 100. So probability of sample space is always 1 because that's a definite event. If an event is equal to sample space, it's definitely going to happen. You saw that in this first example. The definite event I gave you as first example. This is a definite event, means it is same as sample space. So probability of sample space is always 1. So I need to now express probabilities on the Venn diagram. You can actually draw the Venn diagram if they give you probabilities instead of counts. Here the counts are given, 40 and 60, add up to 100. Instead of giving you count, they give you probabilities. Then you use probability 1 for the sample space. And if this is 0.4, then the probability for the outside is 1 minus 0.4, 0.6. See, they match these, 40 over 100, 60 over 100, add up to 100. Add up to 100 over 100 equal to 1. So we can work with the counts. If they give you counts in the problem, then you can calculate probabilities using the count of the sample space. Or if they give you probabilities, then they don't have to give you probability of the sample space. It's always 1. So using your event, you can find the probability of the outside by subtracting from 1. And so we can do our math on the Venn diagram using either counts or probabilities. That's the point I'm trying to make. Either one applies. Okay, going over to exercise 1. In the experiment of tossing a die, E is 3 or 5 false. Write E and E bar as sets. Okay, let me clear the board. Can somebody tell me E as a set?
One, two, three, 4, 5, 6.
That would be sample space, you're saying. Okay.
It consists of 3 and 5.
3 and 5 will be the event. Yes, you're right. Sample space is going to be 1, 2, 3, 4, 5, 6. And the event E given here is 3 and 5. 3 or 5 false. So 3 and 5 are going to be in that event. And then it says, write the E bar. So E bar will be what?
1, 2, 4, and 6.
4 and 6. Very good. Probability of E, it says find the probabilities. Okay, probability of E is 2 over 6. Let's not reduce it. Probability of E bar is 4, right? There are 4 elements here, so 4 over 6. And do they add up to 1 is the next question. Yes, they do, right? 2 over 6 and 4 over 6. Okay, exercise 2 says in an experiment, probability of E is 2 over 7. What is probability of E bar?
5 over 7.
5 over 7. Simply subtract it from 1. 1 minus 2 over 7 is 5 over 7. Okay, exercise 3, probability of E bar is 0.6. And what is probability of E? In decimal form. You can
40%.
yes, it is. So probability of E is 0.4. 1 minus 0.6 is 0.4. And in percentage form, it's 40%. And fractional form, it's 0.4. 0.4 is same as 4 over 10. So equal to 4 over 10, equal to 2 over 5.
I'm sorry. So for exercise 2, the answer would just be 5, 7.
5 over 7, yes.
Okay.
I'm at exercise 4 now. Probability for George to pass the test is 0.4. What is the probability for him to fail?
0.6.
0.6. Okay, I'm at exercise 5. Among the 20 children in a daycare, 11 have black hair. So now this one gives you numbers. So we can go to Venn diagram and put the numbers. Now you have learned how to work with numbers on the Venn diagram when we did set theory. Let me clear the board. And okay, so the first question doesn't require Venn diagram. The other questions may require that. So let's answer the first question. 20 children there are 20 children in the daycare, 11 have black hair, 1 child is randomly selected. The event is child has black hair. Okay, so E is defined as child has black hair. Okay, now how would you describe E bar in words?
Child does not have black hair.
Doesn't have black hair. Okay, so that's how you describe it. And then it says, what is probability of E? That'll be 11 over
20.
20. 11 have black hair out of 20. And probability of E bar would be what?
9 over 20.
9 over 20.
9 over 20. Right, 9 over 20. Someone said something else, but 9 over 20 is right. Basically, there are 11 with black hair, so 9 without black hair. Or you can subtract 11 over 20 from 1 to get 9 over 20, either way. Okay, so going over to exercise 6, statistics show that 20% of college graduates get starting salary of $45,000 or more. If a college graduate is selected randomly, what is the probability that he or she will get starting salary of $45,000 or more? What is it?
20%.
20% or 0.2. What is the probability that he or she will not get starting salary $45,000 or more?
60%.
80%.
0.8.
80%, right?
80% or 0.8, right? Someone said 60%. Do you understand that? It's
Yeah, no, that was a mistake.
okay. All right. Okay, let's go to the event E and F occurring. We discussed this a little bit before, but let's understand it fully. If I'm going to use this example, two events occurring at the same time, that we're going to be looking at that. Suppose that a six-phase die is rolled. The E and F are defined as E an odd number shows, F is number less than 4 shows, less than or equal to 4 shows. Those are the events defined in words. Okay, so sample space is 1, 2, 3, 4, 5, 6. Event E is 1, 2, 1, 3, 5, odd number. Event F is a number less than or equal to 4, so therefore that'll be 1, 2, 3, 4. Okay, then when you actually toss the die, there will be only one number that's going to come up. So we, in the event, we have to list all the elements that will make that event happen. But the outcome is going to be only one. So when I actually toss the die, if it is a 3, then event E has occurred, and event F has occurred because the number is less than or equal to 4. Event E has occurred because it is odd number. If the outcome is, when I toss the die, if the outcome is actually 2, then which event has occurred?
Only F.
F,
Only F.
F has occurred, E has not occurred. So, and also if the outcome is 4, then only F has occurred, E has not occurred. So what are the elements that will make both events occur? 3 is one of them. Anything else?
1.
1.
1. So 1 and 3 are the only elements that will make both E and F occur, right? And notice that 1, 3 is same as the intersection of E and F, right? Intersection of E and F. So it's event E and F occurring is same as event E intersection F occurring. Only if the outcome is 1 or 3, then both event E and F have occurred. That means E intersection F has to occur for E and F to occur. In other words, E and F occurring is same as E intersection F occurring. So that's why the set theoretic intersection comes into play in probability. So if you are finding probability for 2 events to occur, you need to find probability of E intersection F. Okay, so that's why this is the fact you need to remember. Probability of E and F occurring is same as E intersection F occurring. Now, if you're using a Venn diagram, then let me go to the board. On a Venn diagram, 2 events occurring, two events will be shown in 2 circles, and which part represents both event occurring? Intersection right here. So E intersection F is exactly the event of both occurring. And that'll be in the Venn diagram, that is a common section. Okay, so next example is if the question says the event E occurring but not F occurring. So let's go back to the same example. E occurring but not F occurring. E has 1, 3, 5, and F has 1, 2, 3, 4. So what should be the outcome? The outcome is going to be only one number. What outcomes will make the event E occurring but not F?
The number 5.
5.
5. Yes, 5 is the only one, right? 5 is the only one that will make the event E occur, but not F. Okay, so that's essentially same as on the Venn diagram. If this is E, okay, if this is, let me draw that again. Clear the board. Okay, so here's the Venn diagram, and the event E and F are these. And E has 1, 3, 5. So let me write those elements here, 1, 3, 5. And the elements common to both are 1 and 3. Okay, so 1 and 3 are here, 1 and 3. And the remaining elements of E would be 5. 5 is here. And the remaining elements of F would be 2 and 4. 2 and 4 are here. So you can see that the only element that will make E occur, but not F, is 5, right? As we recognized. And that's what we have here, 5. In other words, this section, the part of E that's not shared with F, represents E occurring, but not F. So
I'm just curious, how do we get 1/3 for F prime?
I don't have any 1/3 here. Yeah, the elements 1 and 3, that's what I meant. I listed the elements that are in the intersection. Okay.
Okay, because I'm looking at further into the equation.
No, I'm, you're looking at the probability of the intersection. Is this a question?
Yes.
Okay. The probability of the intersection would be, there are 2 elements in the intersection, 1 and 3, right? So the probability will be 2 over 6. Okay. E intersection F has 1 and 3.
Okay, so then that would just be those 2 out of the 6 in the sample
Right.
set. Okay.
So count of elements, count of the event E intersection F is 2. So 2 in the numerator, and count of sample space in the denominator. I'm sorry, I skipped that, those numbers. Yeah. So yeah, if they ask for probability of E and F occurring, then you had to find the E intersection F and find the probability of that. E intersection F has 2 elements, and therefore probability of E intersection F is 2 over 6 equal to 1 over 3.
Oh no, I'm looking at the example. It says 1/2 minus 1/3.
Which one, previous or way below?
Below, example 4 for you.
Don't worry about that yet. We are not there yet.
Oh, I thought that's where we were. I'm sorry.
We are not there yet. I'm still trying to explain which part of the Venn diagram will represent E occurring but not F. So I just explained E occurring but not F is the outcome 5 in this case, right? Only if the outcome is 5, then E will occur but not F. And if you go to the Venn diagram, the part of E that's not in F is this. So this section of the E represents E occurring but not F. If the outcome is anywhere here in this part, then E occurs but not F. For the F to occur, the outcome has to be somewhere in F. So F will not occur if the outcome is here. So if the problem asks you to show the region in the Venn diagram that represents E occurring but not F, that will be this. The part of Venn diagram that represents F occurring but not E will be which one? F occurring but
The
not
F.
F?
part of the F that's outside the E.
Yes.
So that's this. So this here is E intersection F bar. That's how we learned it in set theory. And this here is F intersection E bar. Part of the F that's outside E. And this one is part of E that's outside F. So basically, all the questions like, what is the probability that E occurs and F doesn't, or F occurs but E doesn't, or E and F do not occur, what area represents E and F not occurring? E or F not occurring?
It would be the outside.
outside the two circles, right? So everything can be figured out on the Venn diagram. And this is why we did Venn diagram in the set theory. It applies in probability theory everywhere. Okay, so let's clear that. And so now let's go to answering that question. What is the probability that E occurs but not F? So I need to find the probability of this region that is part of E that's outside of F. So let's go back to the example that we did, the same example, tossing 2 die, and the event E is, where is that? Event E is 135. An odd number occurs. F is number less than 5 occurs. So 1, 2, 3, 4. And so E occurs but not F would be same as just 5 occurring. So that's why I have described E occurring but not 5 is same as just 5. And the probability of that is 1/6. Only one element is there. So 1 divided by count of sample space, 1/6. So probability of that E occurring but not F, basically it's same as E intersection F bar. So probability of E intersection F bar, that represents E occurring but not F occurring, is same as 1/6, right? There's only one element in there, 5. Okay, so now, if you need to answer any other question, we can actually use the Venn diagram to figure out the remaining sections. So here's the Venn diagram. And we already know how many elements are in each section. We can either use the count or probability. We know the probability for entire E is 1/2. If you look at E, 135, these are the elements in E. So probability of E is 3/6, 1/2. Probability of 4 is 4/6, which is 2/3. So I have marked those probabilities in this Venn diagram here. Half is the probability of E, 2/3 is the probability of F, and we already figured out 1/3 is the probability of E intersection F, because E intersection F has only one element. I mean, 2 elements. So 2/6. E intersection F has 2 elements, 1 and 3. So therefore, probability of E intersection F is 2/6, which is equal to 1/3. And that's the number I have put in the middle here. 1/3 is the intersection. So now we can work out the remaining sections. So E has 1/2, F has 2/3, and this is 1/3. So I can figure out the left side of E by doing half minus 1/3. The half is the total for the circle. So half minus 1/3 there. And this is 2/3 over 1/3 for the right side of F. So half minus 1/3 is equal to 1/6. 1/6. And 2/3 minus 1/3 equal to 1/3. And so 1/6 for the left side of E, 1/3 for the middle, 1/3 for the right side. And if I need E union F, I can calculate that by adding those numbers. 1/6 plus 1/3 plus 1/3. So we can use Venn diagram with probability numbers marked in there. So if they give you count or probability, you can use Venn diagram in either case. So probability of E intersection F bar, which is the left side of E, is equal to half minus 1/3. The half is the probability of E, 1/3 is the section that's shared. So half minus 1/3 will be the left side of E. Okay, so going to exercise 7. For the experiment of tossing a coin and a die at the same time, events E and F are defined as, so tossing a coin and a die. Event E is tail shows on the coin. Event F is even number on the die. Okay, can somebody tell me the answer to the first question? Event E as a set.
It will be T1, T2, T3, T4, T5, and T6.
T1, T2, T3, T4, T5, T6. Very good. Okay, let me write that down. Part A is event E equal to T1, T2, T3, T4, T5, T6. Okay, event F.
I'm sorry, but wouldn't it just be the even numbers? Oh, we're just putting down E. I'm sorry.
Yeah, the coin should show a tail. That's all the event is defined as, which means the die can show anything. So therefore, all of these will be in the event, right? F is even number shows on the die. Okay, can somebody tell me what the elements are?
H2, H4, H6, T2, T4, and T6.
Right, H6 and then T2, T4, T6. Okay. Then it says, find the probabilities, part B. Probability of E is, there are 6 elements there, so 6 over. How many will be in the sample space?
12.
12. So 6 over 12 is half. Probability of F is, there are 6 elements there. So 6 over 12 equal to half again. Part C, find the probability of both E and F occurring. Okay, so for that, you just have to find E intersection F. What do we have there?
T2, T4, and T6.
T2, T4, T6. So probability for both occurring is equal to 3 over 6. Sample space has 12, sorry, 3 over 12. Sample space has 12. So 1 over 4. Part D says the probability that F occurs but not E, F occurs but not E. What elements have F occurring but not E? That's same as F intersection E bar.
H2, H4, and H6.
H2, H4, H6 is right, yeah. One of these, if one of these have to occur for the F to occur without T occurring. So probability for F occurring but not T occurring, not E occurring is 3 over 12 equal to 1 over 4. And that's it. Problem number 8 shows, it gives you probabilities and it asks you for E intersection, probability of E intersection F bar, E bar intersection F, E union F bar, all that question. Clearly that means you have to use Venn diagram. So put the numbers on the Venn diagram and work out the remaining section, just like we did in the set theory. And then you'll be able to answer all the questions. Okay, so I'm putting everything on the Venn diagram. And the left side is E, right side is F. And 0.6 for the E, I write that number outside. And 0.4 for the F. Okay. And where do I put the 0.1?
In the intersecting
Sir?
part.
Intersecting part is 0.1. So what is the probability for the left side of E that's not shared with that?
0.5.
5. Probability for the right side of F?
0.3.
0.3. So what would be the probability for the outside of the two circles?
0.1.
0.1, right. Because 0.3 plus 0.1, 0.4 plus 0.5, 0.9. Both circles add up to 0.9 and the sample space has probability 1. So 1 minus 0.9. These numbers add up to 0.9. So 1 minus 0.9 is 0.1 for the outside. Okay, so now we have all the numbers. We can start answering question. What is the answer to the first question? E intersection F bar.
0.5.
0.5. If anybody is not following me, Please feel free to ask the question. Part B is
0.3.
0.3. That's the right side of F, 0.3. Part C is
0.1.
0.1.
0.1. So there's 0.1 probability for neither E nor F to occur. Okay, very good. So let's do the next problem, exercise 9. This one gives you numbers, just like in the set theory problems. But like I said, whether it's numbers or probabilities, you can still use Venn diagram in either case. So let's work this out with the Venn diagram. All right, I'm clearing the board. And I'm going to paste that picture here. Oops, I lost it. Okay, now it says out of 450 college students, 120 enrolled in science, 220 enrolled in English. Okay, so we'll put those in there. Science, I'll call it S, and there are 120, and English 225, English 225. Where do I put the 450?
Intersecting part.
The 450 college students, it says.
Outside.
Yeah.
Yeah, that's for the universal set. 450 is the universal set, or sample space in this case. So 45 are enrolled in both, so 45 goes here. And then they are asking questions, so we can just work out the numbers first. 120 minus 45 is 75. That's 75 here. And so this section, part of E that's outside of S would be 225 minus 45.
80.
180, right, 180. Now to find the outside of both circles, I add all those numbers. 225 plus 75 is 300. So take away 300 from this, and that's 150. So there are 150 outside. Okay, now the question A is, if I randomly select a student from this class, what is the probability that the student is enrolled in science? Anybody?
120 over 450.
Right, 120 over 450. But so remember, they can be giving you counts, but they can still ask you probabilities. But that means you divide the numbers, the number of elements in the event by number of elements in the sample space. You had to reduce these to enter the answers. So here they're asking for numbers rounded to 3 decimal digits, so you can just use the calculator. Part B, the probability that the student is enrolled in English will be
75 over 450.
225 over 450 is right. There are 225 students in English. Okay, part C, the student is enrolled in both.
45 over 450.
Right, 45 over 450. Part D is the student is enrolled in science or English.
We have to add them, and it's
Right,
300 over 450.
Right, there are 300. If you add these numbers, 300. So the union has 300 elements. So 300 over 450 is correct. Part E says the student is enrolled in English, but not science.
180 over 450.
Right. So the only thing different here from the set theoretic problem is that you had to divide by the count of the sample space. All right, part F, the student is not enrolled in English or, okay, that's a tricky question. student is not enrolled in English. It doesn't say student is not enrolled in English or science. It says student is enrolled in English or is enrolled in science. That would be,
Would that be
75.
300 subtracted by 75?
what
No,
number?
is it 75 over 450?
75. No, let me explain why. The student is not enrolled in English or is enrolled in science. So
225.
225 is all of the E, right? So let me figure out, let me explain what set represents this. So not enrolled in English would be complement of English, right? E bar. Agree with that? Student is not enrolled in English is E bar. Or is enrolled in science means student is either in E bar or in science. That's what it means. So that would be same as E bar union S. It's kind of tricky, but I hope you follow that. Student is not enrolled in English or is enrolled in science. That means he has to be either in E bar or in S. That's what it means. Okay, that will be union of E bar and S. So union of E bar and S would be E bar is everything outside of E, and then when you combine the S, it's everything outside of E combined with S. So let me shade that. That will be, see, everything outside of E is what I have, what I'm shading now. Everything outside of E. Okay. Now when I combine S to it, what happens?
Would it be 150 plus 75 minus 450?
I don't see where you're getting
Would
that.
it be 150 plus 25 over 450?
No, don't rush into that. Let's figure out first what region here represents our answer. I said it's E bar union S, and I have shaded E bar already. So when I take union of S with the E bar, what section is going to be added to this? The shaded region expands to what?
Outside the box?
No, you can't go outside the rectangle, right?
Be
We
all
can't have
the
the
whole circle?
intersecting part because they will be enrolled in English then.
Which section will be added?
No, it won't be added. The intersecting part because they will be enrolled in English.
So would 180 be added?
No, the 40, this intersection will be added. That's what I'm trying to explain. The E bar is everything outside the E. I have shaded that, right? But I have to take union with the S. When I take union, if I take the E bar union S, the S is going to be added to this entire S. So entire S, part of S is already in the shaded region. So the remaining S will be added, which is this, will be added. So that is the section we need to find the probability for. And that would be equal to 150 plus 75 plus 45. Okay, 225 plus 45, 265. So probability for that is 265 over 450. I know it's a tricky question.
Why do I have a question? Why do we have to take the intersecting part? Because it says the student is not enrolled in English. So if we take the intersecting part, it will be.
It doesn't say student must not be enrolled in English, period. It says student is either not enrolled in English or enrolled in science. Are you following me?
No, it says the student is
Okay.
not enrolled in English or is enrolled in science.
Or is enrolled in science. That means the student should be either outside of E, which is E bar, or in S. Okay, so
Okay, thank you.
Got it.
that's why it's a union. Okay, so E bar is, I shaded E bar first.
Excuse me, Professor.
I'm sorry.
Wouldn't Wouldn't it be 270 over 450?
Oh, did I add wrong? I may have added them wrong. Yeah. 75, 80 plus 40, 120, so 270. You're right. Not 265, 270. That's right. So everybody got that? See, the wording is a little bit tricky here. If it said, this, what is the probability that the student is not enrolled in English or science? That means outside of English and science. But it's not worded that way. It says student is either not enrolled in English or is enrolled in science, means either outside of E or in S. So it's union of E bar and S. So that's why the shaded region is the answer, union of E bar and S.
Professor, to get the decimal of 0.6, are we supposed to divide 270 from 300?
Why 300? 450 is the count of the universal set here.
Oh, I'm sorry.
Okay, it's 450. Okay, so mutually exclusive events, we don't have time to cover that, so we will stop here. The homework is already up. I may have to go back there and make sure there are no mutually exclusive events in there. Other than that, the homework is ready for you to do. All right. Enjoy the rest of the day and the weekend. I will see you Monday.
Thank you so much, Professor.
You're welcome.
Thank you, Prof.
You have a nice day.
Okay,
Have
thank
a
you,
good
Professor.
day as well.
Bye-bye.
Hi, Professor.
Yeah. Have a question?
This is Layla. Remember the email that I had sent you regarding the assignments and the extended?
Oh, yes, I did extend it for you. And have you completed those already?
I've completed all of them and including the one that was due today, and all of them I got above a 90.
Oh, you did. Okay. All right. Then I'm going to extend the other ones then. Okay.
Thank you. Thank you also for giving me the benefit of the doubt, and I'm glad I proved myself to you.
You're welcome.
Have a good one.
You too. Bye now.